Fontana Dam slot cut. The reason they cut the slot in the dam is because of what they call an alkali aggregate reaction, which makes the dam grow, which warps their spillway gates.
Dun, dun, dun. How are we gonna fix this problem?
We actually take a slice all the way from the top through the entire dam, 5/8 of an inch thick, about this big, and it allows the dam room to move. So in order to do that, we use a diamond wire saw. And we mount idler wheels at various places.
Do it again.
Now this has a water level about up to here, and there is a cofferdam that you can go down in.
The cofferdam has a cap on the bottom to prevent water, and it's pumped out. Looking at the top view, it's essentially half of a can that is attached to the dam, so no water gets in, so a person can go down in and out of there even though there's water in the lake.
To start, this wire would actually have run up this way across the dam to this traveling pulley that was here, and then back up. This pulley would slowly work its way down, and the cut would slowly work its way down through the galleries for the complete cut until we got to the bottom of the slot. And that is using a diamond wire that is shaped similar to that, where these are springs. These are diamond impregnated segments. It was about a 350-foot length of wire in order to wrap around this thing. Once you start, you never stop, because the dam has such pressure, and it'll actually close around the wire as it cuts down. Indeed, when we got this wire down approximately 20 feet, the top of the slot was closed already. So you had to run 24 hours a day, 7 days a week.
Yeah. You like night shift better?
Took approximately 13 shifts
That's correct.
to make this cut. So basically 6.5 days to cut 90 feet deep and ended up 100 feet wide. So we had to man it around the clock. We had to change the wire out approximately every 24 hours because the cables and the springs would wear out. The diamonds were still okay, so we would rotate in new wires.
First thing we do is cut the slot. The slot requires water. The reason for the water is it lubricates the diamonds and it washes the concrete out of the slot. If you don't wash the concrete out, it will cake up on the wire and stop the wire. For this particular job, we get the water on the downstream side from the lake with heavy-duty well pumps that we pump back up to the top of the dam into the slot. The water comes out of the slot on the downstream side because we pull the wire to the downstream side because the water is going to get pulled into the cut line. So it pulls out on the downstream side, washes down through the drains in the gallery, which we put a drain stop at the bottom to stop any further water from going down. Once it accumulates at the very bottom level, we use vacuums, shovels, and we move it to 55-gallon drums for staging. Once we get 3, 4, 5 55-gallon drums filled is when the fun begins. Then we start our exhilarating workout of dragging the buckets of slurry through a manhole cover to a holding tank for disposal.
This was the third time this cut has been done in 12 years. So that tells you that this dam just keeps growing and keeps growing, so it'll get done in another 5 years. Several of the dams on the TVA system have the same thing. We've done Hiawassee, Chickamauga. They will also have to be done again. They're all a little bit different, but this is just a general profile of what it takes to do this project. The other slot at Fontana was a much smaller slot, and we had no cofferdam down below to mount to. So we mounted the saw up on the road deck and actually had to make a transition cut so we could pull down the road deck. This was much narrower. This was literally only about 18 feet. So it was a much quicker cut. Had ladders from existing slot cuts, so access up and down was quite easy. Had no galleries to worry about on this particular cut. We installed a ladder on the upstream face. The water was actually down below where they had drawn the lake down. So we would just climb up and down the ladder and move a pulley as we went from top to bottom. This cut only took about 6 shifts, 7 shifts, because it was so much smaller, quite easily done.